These are part 2 of equations of circles notes. So we're going to do 3 examples in these notes. The first is to graph a circle. So there are 2 pieces of information you need in order to graph a circle or write the equation of a circle. And that is the center and the radius. So in order to graph this circle, I need to know my center and I need to know my radius. So equations of circles come in the form x minus h squared plus y minus k squared equals r squared. And that follows directly from the Pythagorean theorem. And so my center in general is h comma k, and my radius is r. So in this example, my center is going to be -1 and +5. And my radius is going to be 2. So to graph circles, the first thing I need to do is to graph my center. So -1, +5. I then need to graph my radius. Remember, the radius is the distance away from the center. And so that distance is 2. So in order to graph the circle, though, I need to actually go exactly 2 units. And the only directions that I can do that exactly are the north, south, east, west, the cardinal directions. So directly to the right, directly to the left, directly up, and directly down. These 4 points here form 4 points on the circle. And so now I have enough to draw a circle. My artistry is not amazing, and so my circles generally look a little wonky. So that's not too bad of a circle given my usual drawing abilities. The second example, we're going to find the equation of the circle with center 3, -5 and radius 5. And then we're going to expand it out because it's important to see that done. So if you remember, with all of these, I'm really finding the distance. I'm finding Pythagorean theorem. So if you can imagine that I have a center here, and I know my radius is 5, and I know my center is 3, -5. I'm going to pick an arbitrary point on the circle. And now I need to write Pythagorean theorem. So in order to do that, I'm going to need my right triangle. So Pythagorean theorem again is leg 1 squared plus leg 2 squared equals hypotenuse squared. I know my hypotenuse, it's 5, so I can put that in right away. The trickier part here is my 2 legs. But the nice thing about these 2 legs is that they are a rise and a run, which means they are a change in x and a change in y. And our change in y's are y minus -5, and our change in x is x minus 3. You should remember, and if you don't, this is a nice reminder, that slope is the change in y over change in x. And so I'm using 2 pieces of information when finding equations of circles. First, I'm using 2 sets of 2 pieces of information. First, I'm using center and radius. I need those. Can't write the equation without those. And then the second piece is I use that center and radius, and I'm using that to find legs of a right triangle for Pythagorean theorem. And the legs we find by looking at slope. So slope and Pythagorean theorem are absolutely key for writing equations of lines. So now I'm going to fill in my Pythagorean theorem. My leg 1 is the change in x, so I have x minus 3 squared. My leg 2 is my change in y, so I have y minus -5, so that's y plus 5 squared. And now the only difference between what I've written already and sort of the standard form is that I don't leave the 5 as 5 squared. I actually rewrite it as 25. So that's the first part, writing the equation of the circle. The second part, expanded form, means that I'm going to multiply this out and multiply this out. So you'll remember that squared means multiply it by itself. So really what this says is x minus 3 times x minus 3 plus y plus 5 times y plus 5 equals 25. And then I do my distribution. I distribute my x to both pieces, so that's x squared minus 3x. I distribute my negative 3 to both pieces, so that's negative 3x plus 9. And then I do the same thing for my y's. Y to y plus 5 and 5 to y plus 5. I then simplify. So I've got x squared minus 6x plus 9 plus y squared plus 10y plus 25 equals 25. And then the expanded form is always going to equal 0 on the right-hand side. And I rewrite this so that my x squared and y squared come first, that my plain x's and my plain y's come next. So squared terms, power of 1 terms, alphabetical order, and then I combine all of my constants, all of my numbers that don't have a variable. So I have a positive 9, I have a positive 25, and then because this needs to equal 0, I've brought over the 25, so subtracting 25. And then I just finish simplifying that, cleaning that up. So I have x squared plus y squared minus 6x plus 10y plus 9 equals 0. So these are the two forms of equations of circles, and they serve different purposes and are important, will be important for the rest of this chapter. Our third example takes what we've just done and actually adds a layer to it, because this time we're not given the radius. Instead, we're given a center and a point. However, if I have a center and a point on a circle, I know that that distance is the radius. So I'm just going to label these 2 points. The important part of this is that I'm labeling the 2 points. They may not be accurate in relation to each other in terms of a graph, but all I want to do here really is to find that Pythagorean theorem. So remember, I'm doing Pythagorean theorem, so leg 1 squared plus leg 2 squared equals hypotenuse squared. In this case, my leg 1 and leg 2 are going to just be numbers. So my leg 1 is the change in x, which is 17, whoops, sorry about that, 5 minus negative 2. My change in y is 17 minus 7. So 17 minus 7 is 10. 5 minus negative 2 is 7. So when I plug that information in here, I get 7 squared plus 10 squared equals r squared. 49 plus 100 equals r squared. 149 equals r squared. So the radius is the square root of 149. So now I'm back to the problem I had just a moment ago. I have a radius and I have a center. So again, I'm going to draw that triangle again. It's always, I find it to be so helpful to have this visualization. So my center is at negative 2, 7. I know my radius, it's square root of 149. And now I'm finding the equation, so I need an arbitrary point. Again, I draw the right triangle. I find my legs of my right triangle, so change in x, change in y. My change in y is y minus 7. My change in x is x minus negative 2. Set up Pythagorean theorem again. Leg 1 is my change in x, so x minus -2 is x plus 2, quantity squared, plus my change in y is leg 2, so y minus 7, quantity squared, equals my radius, which is the square root of 149 squared. And just to clean it up, I don't want to leave this as the square root of 149 squared, so I rewrite the left-hand side as is. There's nothing to simplify there at this point. And I square the square root of 149, so equals 149. So this is one form of the equation of a circle. The other is when I expand this out. So when I expand this out, remember I've got x plus 2 times x plus 2, that's what squared means. Y minus 7 times y minus 7, that's what squared means, equals 149. I'm going to do this process a little bit differently than I did in the last example, and a little faster because there's some patterns here that I can cash in on, as they say. So whenever I have a perfect square like this, the pattern is x squared plus 2 times 2x plus 4. So here that's going to be y squared plus 2 times -7y plus 49 equals 149. And then I can simplify the middle terms, and I'm going to, again, do this a little bit faster. I'm going to rewrite this at the same time, putting my x squared and y squared, and then that's plus 4x minus 14y. Still have my positive 4, still have my positive 49. But then again, because I want the equation to equal 0, I subtract 149 on both sides. And then I just combine those like terms at the end. So that's -100 plus 4 is going to be -96. Equals 0. And there's my second form.